All right, welcome. We're going to bring up our next speaker. Our next speaker is Mr. Justin Carney. He's a student at Augusta University, and he's going to present his research on analysis and literature review of cyber-physical attacks on building enterprise security. Mr. Carney.
Hello and welcome, everyone. As she said, my name is Justin Carney. I am a PhD student at Augusta University with the School of Computer and Cyber Sciences, and today I will be discussing my research on cyber-physical attacks targeting building enterprise security. Cyber-physical systems, or CPS, are defined as integrated network computers with physical processes, and they are essential for functions like managing traffic at intersections or regulating climate within the building. Some of the key components I'll be discussing in this project are HVAC systems, RFID access control, and elevators. Today, many cyber-physical systems and weapon systems heavily rely on cyber-physical systems and military infrastructure. In a recent news article, there was an issue where Ukrainian intelligence hacked into the Russian missile systems in Russian military defense. And this showcased and exposed the holes or vulnerabilities in Russian military infrastructure. Our research takes vulnerabilities that are similar to this, assesses those vulnerabilities, and then outweighs the mitigations. And so this is a literature review of many of the papers we reviewed to help pave a way to our research. One paper was talking about the use of smart devices in buildings. And so today, many buildings have smart thermostats, smart refrigerators, and things like that. And if a threat actor were to gain access to any one of those systems, not only could they shut it down or tamper with it, but they could also use it as a gateway to access other systems throughout the building. One of the other papers we reviewed was the use of digital twin simulations, where you have the physical prototype of the item you're testing and then a digital copy. And let's say I have 3 tests, A, B, and C, and I want to test A and B on the physical prototype and then test B and C on the digital copy. At the same time, I would see different results that would be testing the same product. And our objective, as I mentioned, was to test different vulnerabilities and simulate attacks on our systems and to come up with mitigations on each individual module. Our security framework, we have several different defense layers within our product, and so that when one system is being tested, the other systems will continue to remain as intended. In the paper that I mentioned, when a threat actor could gain access to one system, they could use it as a gateway to access others. Our framework prevents that. And so that when we are safely simulating and testing the efficiency of the systems, the others will continue to function. This is a blueprint of our simulated building. There are 3 floors, and each floor is equipped with a temperature sensor, a LED motion sensor, and in the basement we have the HVAC, and also there's the elevator. The first system we tested was the RFID system, and we discovered that this was vulnerable to cloning and eavesdropping, where a threat actor could clone a badge and use it to gain access into the building. And the way we mitigated this was with secure communication channels or encryption, and so that when it sends the data to the circuit, it will recognize and understand that if their badge is legitimate or not. This is the module of our RFID system, and the way this would work is that the user would scan the RFID card on the reader that would send encrypted data to the Arduino Uno, which would then validate if the data is permitted or not, and that would thus illuminate a green or red LED if they have access, if their access is granted or if it is denied. The next system we tested was the HVAC system, and we discovered that this was vulnerable to temperature manipulation. And why would this be important? If you've had a chance to go visit the Georgia Cyber Center down the street, several rooms in that building have these big, tall servers. And those servers are kept in rooms that are relatively cooler than the rest of the building. And if a threat actor were to gain access into the HVAC system, not only could they shut it down and tamper with it, it would cause those systems to overheat, potentially causing a fire, or that would mess up other systems within the building. And so the way this was mitigated was through redundancy systems or backups. And so that if it's hacked, a backup generator will kick in, and so that way it can continue stable operations even during an attack. This is the layout of the HVAC system, and this one's all about the temperature sensor. So if the temperature sensor, let's say the room is too warm, it will send encrypted data to the Arduino Uno, which will then send data to the fan, and that will start spinning to cool the room down. If the room is too cold already, the opposite will happen, where the fan will start to slow down or stop. Lastly, we have the elevator system, and we discovered that this was vulnerable to unauthorized access and hijacking. And so, again, the Georgia Cyber Center down the street, there are several floors within those buildings where not only do you have to have a badge, but you have to have a certain amount of security clearance to get onto those floors and in those rooms. And if a threat actor, let's say they walk into the building with a cloned badge and they board an elevator and they gain access to any of those rooms, they could compromise the security that is being conducted in those areas. And the way that this was mitigated was with backup systems. And so that if there is an attack that is sensed, then the backup systems will kick in and prevent the threat actor from gaining access to the elevator. This is the layout of our elevator system. And just like in an actual building, on each floor you would press the button and you would get a reading saying that the elevator is on, I don't know, let's say you're on the top floor and the elevator is in the basement for whatever reason. You'd get a reading saying that the elevator is in the basement and that it's coming up to your location. And the way this was laid out is that the person on the designated floor would press the button. That would send data to the Arduino Uno for the motor to start spinning. And the ultrasonic sensor would give readings stating that the elevator is on whichever floor. The other unique thing about the ultrasonic sensor is that when it senses an object, it is programmed to tell the motor to stop only on the floor where the button is being pressed. And so if the person's on the top floor, the elevator's in the basement, there's a floor in between them. And if the motor starts spinning and the module starts to approach the middle floor, it will not stop because there's nobody on that floor pressing the button. It was designed that way on purpose. Then the question becomes, is how were we able to measure the effectiveness of these systems? We used a principle called real-time monitoring. And real-time monitoring allows us in real time to measure the effectiveness of these mitigations as we ran these tests. And so with this, we were able to immediately detect and recognize these attacks as they were coming out. We had a tester and an attacker. And so when the attacker would commence the tests on a system, if there were early stages or early signs of an attack, we were able to immediately find it and correct it. And we were able to minimize the downtime, the time in between each test, as our results continued to grow. And by doing this, of course, we were increasing the situational awareness of these attacks as they occurred, and the adaptability to evolving threats. As these threats continue to grow and change, just like a virus, and we were able to see the early stages of these attacks, and if there was, in the case of the HVAC system, an attempt of SQL injection or elevator control tampering, we would recognize those early stages and mitigate them. The results in what we did, I have a graph in the next slide I'll show, is that we introduced several different mitigative strategies to our simulations. And for recommendations on each system, we recommend keeping everything updated. Make sure you have the latest Google update, and make sure that your computer is frequently updated to prevent attacks from happening in the future. This is a graph of our results that we, in our tests, our testing phases, that we measured. And so, just a reminder, with the RFID system, we discovered that was vulnerable to cloning and eavesdropping. And in the first few stages of our attacks, we did not introduce our mitigative strategies, and this was done on purpose, because we wanted to show that there was an increase in risk and a decrease in resilience. We introduced our mitigative strategies a lot later of the simulations to show that the resilience was increased and the risk was lower. And so in the RFID system, as we introduced the protocols of secure communication channels and encryption, it became more difficult for our attackers to be able to breach the RFID system. And in the HVAC system, same thing. In the earlier stages, we did not have our mitigative strategies, just because we wanted to show that it would be easier for the threat actor to be able to gain access to the HVAC system. And in the later stages, we had the same results where the risk was decreased and the resilience was increased. And the same case with the elevator system. As the data went over time, there was a significant increase in resilience. To conclude, and what we talked about was how did we find mitigations for these strategies? Well, we tested through simulated attacks on each one of those systems. And we were able to effectively mitigate each of our test scenarios. The path forward is one thing we were thinking about was how to implement artificial intelligence into the use of cyber physical system security and even in security in general. The way these viruses grow and change, they're very, very different. Think of the COVID-19 virus. That's a growing and changing virus, and each vaccine that comes out is supposed to be better than the last, an improvement of the last. And so going back to the last block here, the adaptability to evolving threats, we can use artificial intelligence to adapt to the threats as they continue to grow and change. We can better recognize the early stages of those attacks before they take place. Or at least we can attempt to put in preemptive measures so that way, if there was an attack, it would not be a large issue than if we had not implemented artificial intelligence. And I would like to take this time to thank my teammates, Charles Smith and Nina Robinson, who I worked with on this project during the fall of 2023. And a special thanks to our faculty sponsor, Dr. Jacob Cox with Augusta University and Tritium. And thank you to our project advisor, Dr. Jason Orlowski with Augusta University. Thank you both for your wisdom and guidance on this project moving forward. And these are some more of the references and papers that we reviewed to help adapt and pave our way to our research. Most of them talk about modeling cyber physical systems, and that's really what we did here. Is we had something and we attacked it in a safe simulated environment, and then measured the out risk and the risk. Okay. Thanks very much. Is there any questions? Yes. So, not really, but I do believe that with. Oh, okay.
So I got to implement a solution to a physical threat. How much does that cost?
So, because he asked if it was how much would it cost for an actual threat, because this was a simulated building, we would have to think about many other external factors, as in the cost of air conditioning or the cost of an elevator. If it's damaged, how much would it cost to replace it? And so that would be a lot that would be factored in. That wasn't factored into this project because it's a simulation. But in the future, if this is brought on a larger scale, that is something that we would implement. Yes?
You mentioned encryption as one of your mitigation techniques and pretty heavily used in networks today. And I'm assuming it's probably from Arduino to Arduino on how you're doing that. But in your literature reviews, you run into any reasons why you're not seeing encryption heavily used in the cyber system today outside in regular environments?
Not at the top. He asked if we saw any reasons why encryption was not used in cyber physical systems. I personally didn't see any that we came across, but it can be very, very, very iffy in that area, where because these systems, most of them when they're tested, most of them don't have encryption, because they're not thinking that, oh, maybe this could be a problem, but maybe it won't. Like this phone right here, not saying that this is not a threat, but it could be. Someone could hack into the microphone and could be listening in on this presentation or and whatnot. And it is important for encryption. In some of the papers, I did see some. Actually, I did see some the smart devices in those buildings. They did use encryption, but what was different is that they didn't have the framework that we implemented, where if one system was tampered with, the other systems would continue to function as intended. So that's what was different. Yes.
And you say you're going to use AI. I mean, could you think about, are you going to use AI in description or
So we asked if we're using AI in descriptive or predictive sense, and the way that would be conducted is, of course, in the simulation. We would have a platform, and I believe we would use the digital twin simulation. That would make us, we would be able to see the results twice. And if I had a series of tests that I would run with AI, I would test those on the, let's say, on the digital copy and on the physical copy, both at the same time. We would be able to predict those issues after we had gathered data. We would have several different tests that we'd run through. So we'd go through test A, and then we'd gather the data, say, okay, this is what this test would look like in these first few stages. And then we would move on to the next one. And after we have a few tests, we would then implement AI, and then we would run those same tests again, and it would be able to determine if it can recognize those early stages or not, after we'd already gathered the data from our tests without AI, and then we would implement AI. And so it would be, hopefully, it would be able to predict and see the early signs of those attacks. Yes?
When it came using the redundant system, what kind of controls do you have in place to determine when a system wasn't performing the way it needed to, when you switch over to that other system?
So he asked what redundant systems did we have. For the HVAC specifically, it was a backup motor, and so that if there was tampering or with the motor and the fans, then we would have a secondary control system that would kick in and hooked up to a secondary power source as well. And with the elevator, the same thing. There would be a secondary motor that we would have that would kick in if that one was tampered with.
Was that more about the binary, like if the motor shuts down?
Yes.
That would not, like, it's not performing.
Right. Yes.
The miner has good matrices that focus on either attacking or defending a cyber system. They recently came out with an industrial control system one. I was curious if your research, you see the future of it over the next few years, do you think that you could codify enough techniques, tactics, and procedures to be able to eventually come up with a cyber physical system matrix?
Absolutely. Absolutely. With, of course, the proper funding and guidance, I believe that is something that is definitely a possibility in the future. Yes. More questions?
One last one.
Yes.
On your real-time monitoring. So was that, were you using kind of systems to detect anomalies, or was this like just actually monitoring, like a human being monitoring?
There is software out there. We didn't, because of time, we were not able to implement the software, but we did have someone there monitoring as the tests were commenced. Yes.
Great job.
Thanks.